Welcome back to the second video. This video is going to be focused more on the equations of lines versus the slope that was in the first video. So we'll go ahead and write that down. There's going to be mainly two equations that we're going to be focused on here. The first one is going to be the point-slope form. And then the second one will be the slope-intercept, which is more common for you guys. And then I'm going to show you guys the last one just so you guys know it's there, but we don't use it very often, and that is the standard form. So I'm going to go ahead here and write each form, and then we're going to talk about how we can use them, how we can create equations, and then how we can also graph them. So the first one is point-slope form, and this you're only going to really use when you're given a point and when you're given a slope, just like it sounds. So the form is y minus y1 equals our slope, which we talked about in the last video, times x minus x1. And here, the y1 and the x1 come from the point. Okay? And then m is the slope. So those are really all the things you need. Basically, you'd plug those things in, and then you would simplify, and you'd be done. The second form, slope-intercept form, is the more familiar to most of you, which is y equals mx plus b. Here we have that the slope is m still, so m is the slope. But then the different part here is b. b is the y-intercept. And what that means is it's where the graph hits the y-axis. And in case we have forgotten, remember on our grids, the horizontal is the x-axis and the vertical is the y. So it's where the line hits the vertical axis. And that would just be one number, and it could be positive or negative. So here you'd be calculating slope, and then you might have to either calculate the y-intercept or maybe they would give that to you. And then last but not least is the standard form. Standard form is when the x's and the y's are all on the same side. So that's ax plus by equals c. And then a, b, and c are just numbers. Okay? Typically they're going to be positive numbers, but most of the time there's going to be numbers, x's and y's on the same sign, equal to some constant c. Okay? Now that form, we don't usually leave in that form because we convert it to slope-intercept or something similar that it's easier to graph from, but I just want you to recognize that that's there in case you see it later in your practice problems. So let's go ahead and practice just graphing lines. So if I start off with the example, I want you to graph the equation y equals 2x plus 5. So first, let me get some graph paper in here. If we go ahead and start graphing that, this is that slope-intercept form. So this is our slope. And then this here is our y-intercept. I always start by plotting the y-intercept first. Remember, this is the y-axis, so we're going to go up 5, 1, 2, 3, 4, 5, and plot a point. And then our slope, if you remember from the last video, it's positive, which means we're going to go up and to the right or down and to the left. So I'm going to go up 2, over 1, because a slope of 2 is the same as 2 over 1. So up 2 over 1, and I could do that a couple times, making sure that I get enough points to draw a nice straight line. You always want to make sure you graph a whole bunch. The other thing I will be looking for is that you are graphing and putting arrows at the end, because for lines they go on forever. Okay? So there is one in slope-intercept form. The second example would be if I give you something like this. Let's say y minus 5 is equal to negative 3 times x plus 1. So in this form, we know what our slope is. We know the slope is negative 3, but we can't tell what the y-intercept is. So what you could do here is simplify and get it back into the point-slope form, or slope-intercept form. So I'm going to distribute the negative 3. So y minus 5 equals negative 3x minus 3, and then add 5 to both sides. And that gets us y is equal to negative 3x plus 2. And now we can go ahead and graph that one. Start at your y-intercept at positive 2, and then graph our slope, so up 3 to the left 1, so 1, 2, 3, or down 3, 1, 2, 3, and to the right 1. And plot those points a couple times, down 3, right 1, until we have a nice straight line here. I'm just doing it in green just so you can see the difference. So one is a positive line, one is a negative, and then we'd be done. Okay, so you can transform any equation into slope-intercept form. You just might have to do a little bit of work to get there. So now let's practice writing equations. So if I give you some information, for example, I might give you that the slope is -3/4, and I give you the point, let's see, -2,5. Then I want you to write the equation for this line. Because I give you a slope and a point, we're going to use that point-slope form. I'll just write that here. And all we're going to do is go ahead and plug some stuff in. So here is our x1 and y1, and then we already have the m, so we can plug what we know in. So we know y minus our y1, so -5, is going to be equal to our slope, which was -3/4, and then times x minus our -2. Notice that I wrote the negative and the negative back to back because we want to make sure that we don't forget that there's two negatives there. Okay, so that's always really important to be really careful with your signs, so that way if it becomes a positive you can write that down. So now if we simplify, we get y minus 5 equals -3/4 x. And then if I multiply -3/4 times 2, we get -3/2, always leaving it in a fraction if you can. And then add 5 over to the other side. And when we simplify that, you get -3/2 plus 5 is positive 3.5. Or you could write that as 7/2. Same thing, if you put 3.5, that's the same equation, and we'd be done. Now if this asked you to leave it in point-slope form, then you would just leave it here. But most of the time we're going to be using it to graph, so you want to put it in that slope-intercept form. So simplify it down and get y by itself. Just make sure you read the directions and use what it's looking for. In example 4, we're going to give you only 2 points to write an equation of a line. So I'm going to give you the points 0, 3, and the points -2, -1. Here, we don't know slope or a y-intercept, so we need to do some calculations first. So I'm looking for the equation of the line. So I'm going to first figure out what slope is, because no matter what form we need, we know we have to use the slope. So I'm going to go ahead and label x1, y1, and then x2, y2, and start plugging in. So we'd have -1 minus 3 over -2 minus 0. And if we simplify that, we get -4 over -2, which reduces to +2 over 1. Now we have our slope, so we can choose to use point-slope form or slope-intercept form. Obviously, since we have a point and we have a slope, that'd be really nice and easy. But we also can use our slope-intercept form, and I'm going to show that method here, because some of you guys might like that method just a little bit easier, so might prefer it over point-slope form. So if this is our slope-intercept form, we know we have our slope was 2. But the problem is we don't know necessarily what the y-intercept is. But remember, a y-intercept is where it hits the y-axis. So the point 0, 3 is actually on the y-axis, which means that our b value is actually equal to 3. And if you didn't see that right away, no big deal. What you could do is plug one of the 2 points in. Let's say I'm going to work with this point here. I'm going to plug the x and the y in to my x's and y's here, and I'm going to solve for b. So I could plug in -1 where there's a y, and then plug in -2 where there's an x, and we're calculating b here. So if I solve, we get -1 equals -4 plus b. I could add 4 to the other side, and we get that b is equal to 3, which is that same ordered pair here, 0, 3. And now we have to write our final equation. So we'd have y equals +2x plus 3, because our 2 was our slope and 3 was the b value that we just calculated. So there's more than one way to write these equations. You can first calculate slope if you need it, but then secondly you could use point slope form, you could use slope intercept and plug in a point into x and y, or if they give you the y-intercept right away, you could just plug that number in for b. And the only time it's going to be a y-intercept is if the x value is 0. So that's really important. Y-intercept is when x equals 0. So just be very careful there that you don't plug in a y value if the x is not a 0. Okay? If you have any questions about either of those examples, let me know, but that's really the majority of the types of equations you're going to see. The only other type of equation you might see that will kind of trick people up occasionally is if you get slopes that are not nice numbers. So for example, if I give you the points -2, 6 and 5, 6, if you calculate the slope, we'd get 6 minus 6 over 5 minus -2. That's 0 over 7, which reduces to 0. So what kind of line do we have when it's a slope of 0? Well, if you remember from the first video, that means that we're going to have a horizontal line, which is going to look something like this. So you could go ahead and plug into point slope form if you wanted, or slope intercept. Let's use slope intercept. So we just found our slope was 0, so y equals 0, x plus b. We don't know the y-intercept yet, so let's pick one of those points to plug in. So I'm going to plug in 6 for the y and 5 for the x and solve for b. 0 times 5 is 0, so we get 6 equals 0 plus b, or that b is equal to 6. What that means is all we're going to be left with when we write our equation is y is equal to 6, because 0 times x will always be 0, so we don't have to write that. It would look something similar to this. And if there's ever a 0 there, you don't want to write it. So any horizontal line will always be y equals a number. If it's a vertical line, so that would be when your slope is undefined, that's going to be x is equal to some number. So those are very important little things to maybe add to your notes, because a lot of those times vertical and horizontal equations get people a little tripped up. Just be really careful. If you know it's going to be horizontal, make it y equals a number. If you know it's going to be vertical, make it x equals a number, because it hits the x-axis. And that's it. So plenty of examples here to get you started. If you need me to walk through more examples with you in class, just let me know. That's it for today. Thanks for listening.